Hello. So, what we're going to be talking about now is the ultimate Pythagorean identity. We can use this Pythagorean identity to help us with a lot of things. So, the ultimate Pythagorean identity says that sine squared theta plus cos squared theta is equal to 1. We proved that because if you're using right triangle trigonometry, you just use the Pythagorean theorem to get this formula. It is very, very useful. So we're going to use it right now. I want to point out just a couple of other things here. Here we have the unit circle. I have labeled my x-axis. X is cosine, y is sine. There's a beautiful song that you might want to hear, and it is sung to the tune of Frere Jacques. Here I go. X is cosine, X is cosine, Y is sine, Y is sine, on the unit circle, all the time, all the time. All right, everybody sing it. Just kidding. But if you forget that X is cosine, Y is sine, you can recall that song, and it's just so fun to sing. Okay, so what I'd like to do is this little application problem. Without further ado, let's get started. Find cosine theta when sine theta equals 3/5 and theta is acute. So I just need to find the value of cosine theta. Notice how it's not saying find theta. I just want the value of cosine theta. And we can use the fact that sine and cosine are connected using this Pythagorean identity. So I'm just going to sub in. Sine theta is 3/5, so I have to do sine squared plus cosine squared is equal to 1 using that Pythagorean identity. All right, so I've got 9/25 plus cosine squared. And I'm going to write a smart version of 1 here. I'm going to write 25/25. Reason being is because I know I'm going to have to subtract that 9 over to the other side. So cosine squared theta, 25/25 minus 9/25 is 16/25. Last but not least, I need to square root both sides. So I've got cosine theta. This is convenient. The square root of 16 is 4. The square root of 25 is 5. And I've got a plus or minus in front. So now I'm wondering, okay, why do I have a plus or minus and which one do I select? If you look in the original question, I used the sine equals 3/5, but I ignored the fact that it said theta is acute. Okay, so when we're looking up at this unit circle, theta is any angle that is drawn in our unit circle here. So, oopsies, I could have started, okay, I could have started, you're always going to start from the center, but then you're going to draw going out. So theta could have been something like this, and in that case, if I drew this theta, that would be obtuse. Why is this relevant? Well, if we think about the fact that x is cosine, y is sine, x would be negative in this case, and sine would be positive. So if I change this and it said obtuse, my answer here that I would select would be the negative one. But since it's saying acute, since my angle, oopsies, is acute, what it's telling me is that I'm drawing with the eraser. What it's telling me is that my angle is in quadrant 1, where cosine and sine are both positive. Therefore, I will pick the positive value here. So cosine is 4/5. An extension here could be, they could say find the other trigonometric function. So say they want a tangent. From here, we know that tangent theta is equal to sine over cosine. And so if they were asking me about tangent, all I'd have to do is sub in 3/5 for sine, cosine is 4/5, and so my value for tangent would be 3/4. Okay, so just a little extension. And that's it. Using this Pythagorean identity is very convenient.